Waterqualitydata.us is the location for the water quality portal. And at the first page, you'll see, I'm going to hide this a little bit. You'll see just the home page. There's a lot of resources on the water quality portal. Just like we have for WQX, the water quality portal has information on web services and FAQs and fact sheets for how to download data. It's a really great resource, but for now we're just going to work on the download data. So you just can click on this little square, little fancy square, to download the information. A couple of you guys have asked, is my data there now? So I know you asked in Florida, and then you also asked. So here's where you can actually practice and see what data is available for your organization, if they have. So let's talk about the download information to start. So there's 3 large areas that you can download query data by. To note, the least amount of parameters you put in, query parameters, the faster it will be, because it doesn't have to query for all of those things. So if you're in the United States and you're putting your state, you don't also have to put your country. It doesn't matter. So for the Florida example, we can put the Florida down. You can type Florida in. You can put in your county. You can look at the point location, so within a lat long, like a buffer, and then a bounding box as well. But what I really like to use is specifically the organization ID. Somebody tell me an organization name that they think the data is in the portal. Anyone? You don't want to? Who's got data in the portal? Yes. You just tell me the name, actually. South Carolina.
South Carolina Department of Health and Environmental Control.
So you don't have to know the org ID to download the data. So you can start typing in the organization, South Carolina. Yeah, it was Department of Public Health. So I typed it in right here, and then it showed me the org ID to lead with, right? But sometimes that's hard to remember. Sometimes people who want to go get your data from the portal, they don't know that either. So they can just type in your org ID, and by selecting that, I can now go get data from South Carolina. It'll let me select it. There it goes. All right. There are some other things you can query by. So for example, you can query by site IDs if you know it. That's that monitoring location ID you put in and loaded, okay? But not everybody would know what that location ID is, but if you wanted to see a specific data set that you loaded, you can do that. You can download by HUX, you can download by media, water, biological tissue, characteristic groups, nutrients, bacteriological, those kinds of things, characteristics specifically. So if you're looking for only total nitrogen, you can get just total nitrogen and not get all the nutrients back. So you can do a download on any of those things. Project IDs, you know what those are now, why that exists on the portal, because you loaded that. These are pretty self-explanatory terms in which you can query the data by. We do have this upstream, downstream data search. So Jim could do a much better job than I explaining how this all works. But essentially what it is, it's using HUC12 outfalls. Yes?
That's one of the options, yes.
Okay. And
HUC12 outfalls or active USGS stream gauges. Okay.
So these are all these dots right here. Okay, and so by selecting a dot, you can say, I want all the data from upstream this location or downstream this location. I want all the data upstream on a tributary or down, or a main flow line or with trips. So you can get entire watersheds in seconds. So let me show you. They may just be taking a little bit to load. So I'm going to find a place. I'm from Illinois, so I always use them as an example.
Anytime you don't choose New Orleans.
So I just selected a site location in Illinois, and I'm saying navigation type. I want to downstream. I want to get all sites in the water quality portal downstream this main path. My distance, I didn't put in a distance. I want you to give it all to me. So I hit navigate, and then all this information is indexed at those HUC12 outfalls, and so it's going to do the downstream. And what you'll see when it comes back is how much data it just navigated all the way down to New Orleans, essentially, right? Just that quickly, it knows how much data is in the portal. And then simultaneously, you can see the guys are going to get into a lot more about web service calls. However, the web service calls for that exact downstream query is all right here. This is all that data. If I for stations, I could copy that, put it in a URL, put it in a map, and now I have all those stations for that main path all the way down to New Orleans. So that's the power of this. So it's a really neat way to query data. So if you're looking for data for a specific project, this is a good project to do that. You can also do show sites on mapped, so you can kind of see sites that are in your area. I'm not going to necessarily demonstrate that for time purposes, but I encourage you to explore that. We have different types of data. So as you loaded data, and I think it's just really helpful that you've already loaded data. So you can download the site data separately from the project data, from the results data, and that's a lot of what these are, what these radio buttons are. So I want organization data, so that would be the South Carolina information, where the location is, who their contact person is for that data, all of that. The monitoring location weights, that's a very NARS specific item. We have sample results for biological, so you can just see all of these options. These are just all the different types of data you can load. But for purposes, I'm just going to get rid of, I am going to, I don't want to get all these. You can download the sample results and simply just hit download. It's going to be a comma separated file. You can do tab separated, you can do Excel. What I like to look at a lot of times, because our default, which I always mean to say to Jim, so now's my time, is that our default is zip. I would like our default to be no. I don't want our default to download a zip file. I want it to be a CSV.
And I would say it will be sad sometimes because you'll download it really that until we're on the cloud, we're going to keep the bandwidth 1/10 what it would otherwise be.
Okay, so we'll keep the zip until the cloud, but once the cloud happens. So you can see here in this URL it says zip yes. So a lot of times when I'm downloading the data, I change it to no. Don't tell Jim. Yeah, so this is how you download the portal. This is the information. You can literally right now type in your state, type in the organization you're interested in, select the radio button you want, and hit download. You can, I want to clear these out actually, because now I have all this information from that upstream search, so I don't want to keep that. So I'll just show you how that works. And then it gives you a like an instant response. So for example, if I want to see how much information is for South Carolina, if I select that, and then I just hit results for download, I hit sample results, there we go, sample results, and then I hit download, the first thing that's going to respond is how much data South Carolina has put in. Wow, well, 1.3 million results from South Carolina. No wonder he raised his hand. 2,500 stations, right? So this is what you see first, and you can see that all of that came from, we have STORAT, which we would eventually change, but you can see the breakdowns that comes from NWIS, USGS, and stuff like that. So that's how you download data. Any questions? Yes?
If you wanted to do multiple hops or like a general area, can you do that in here as well?
You could use, essentially, once we have the cloud service working, you could do like a bounding box. So you could put the north, west, south, east on it.
You can put in as many hops as you want, though.
Yes.
Yeah.
So
any level of two-digitness, like 2, 4, 6, 8, 10, 12, that all will work.
it's like all separated by a semicolon.
Okay.
So then it would be 14, 35, 68. So you could do it like that if you wanted a 2-digit husk plus an 8-digit husk.
Okay. Yeah, I'm just thinking of like our statewide rotation assessment process. We want to gather all that data.
Mm-hmm.
We want multiple agencies, really everything from this space.
Exactly, yeah. So I don't know if people on the webinar heard, if you're looking for multiple HUCs or you're looking for watersheds, but also data from other organizations, that's the power of the portal, right? So by using spatial and not a location or an organization, you're getting other people's information. Yeah, absolutely. Anything else?
And just a note, HUCs, if you can use a HUC because you know what's going on in that space, those the weakest point in the portal right now until we move off of Oracle Spatial, which is part of the cloud migration, are the geospatial queries. Those bounding box and radius queries are the weakest part of the water quality portal. So if you know other relevant geospatial information, use that instead.
So for those folks on the line, Jim noted that the geospatial queries here at the top of the download interface, this place, well, actually, the point location and the bounding box are the slowest portions right now because we're not on the cloud. So until we're moved to the cloud, he does recommend you use things such as HUC to do those kinds of downloads, or even counties or states.
We had a question come in from the webinar. What if we are interested in looking at tribal data for specific areas, such as a state like California?
Yeah, so something we're working on actually is right now, you'd have to select each organization itself. We are looking at organization type and serving that information out. We've been talking with Jim about that, but that's kind of been sitting on the back burner with the cloud migration. But yes, we're definitely looking at that. So if you wanted to just say, if you knew the tribes you were looking for specifically, you could select them individually. It's not beautiful, but it's our workaround for now. Anything else? All right, now we're getting into the nitty-gritty. I showed you the web services down at the bottom. What's nice is Jim has made it so easy to find web services. You don't have to develop them yourself. You don't have to compile them. But here we go, Dwayne, wherever he is. Yeah, it's his turn. Yeah. But to stopgap some time, like I said, all the web services are down here. You hit Show Web Service Calls. We also have some ArcGIS Online ones, but these are all the data ones. And then once you select a different button and you hit Show Web Service Calls, it switches them up, right? And the man of the hour. All right. There you go. Dwayne?
Okay, so I'm going to give you the 5-minute or slightly more introduction to what is a web service and how that fits within the water quality portal. Let me just change something real quick so the folks online are seeing the right thing. Okay.
There we go. Okay.
We're good. Okay, so what is a web service? So a web service basically provides the ability for one computer to talk to another computer in an automated way. So it uses some sort of standard mechanism for making that communication back and forth. It allows for the data that's in one system to really be easily incorporated into another system. So for example, water quality portal data can very easily be incorporated into your own web interface where you want to explore that data. It's really everywhere. How many of you checked the weather this morning or today at some point? You used a web service when you did that. So the way that that basically works is your phone uses your location. Your location becomes an input parameter. So it figures out where you're at in space, turns that into a zip code typically, and then it takes that zip code as the input parameter and sends that and fires that off against something like weather.com or some other weather service. And then that computer that's at weather.com responds back with a file that has information about the weather in your location. And then your phone turns that into pretty pictures and information for you. But all that's going on there is this idea of a web service. The water quality portal is built on this exact same concepts, exact same functionality. Everything that Laura showed you, there's an underlying web service that made all of that happen. And what's really cool about it is that once you have the data exposed in this way, it allows you to be able to incorporate that data into all kinds of other applications. For example, I can use an Excel spreadsheet, I can push a button, and the data will magically show up in my spreadsheet. You can use tools like R to do your own analyses, and you don't even have to go off to the water quality portal web interface at all. You just basically give it a URL that has the data that you want, and it'll go off, grab the data, bring it back to you in a file that you format that you want, and then R can just start running with it right away. So incredibly powerful capability. Why is it not changing? There we go. Okay, so I'm going to get a little geeky right now, so I apologize. But this is important. This is an important part for you to understand kind of how does the water quality portal implement a web service. So if you've ever taken a look at the URL, the water quality portal, basically the web link that the water quality portal creates for you, it's basically is creating the web service for you in that URL. The type of web service here, and you guys can show off your web service knowledge to other people, this is a REST-like web service. It's not completely a REST service. I think the true geeks, I think Jim would probably say this isn't really a REST web service, but I like to think it is. So basically what it is you can give it a URL, and that URL will resolve to a set of data. And it's the way the water quality portal is structured is that there's the base URL, which is pointing to the water quality portal as itself. So that's that top part, that waterqualitydata.us/data. So that's the base part of the URL. That part is always the same. All of the different services and functionality or the data types that you're trying to get always start with that. The next piece that you add to it is the service, or what's the question you're trying to ask for. You can ask for station information, you can ask for organization information, project, or summary monitoring location, or result, which is often the typical one, right? So that's the name of the service, the result /, that's the name of the service. And then there's some action. All of the water quality portal services, there's only one action, that is a search. So you're doing a search action. That's followed by a question mark. And then everything that comes after that question mark are your input parameters. So what is it that you're looking for? And there's a whole slew of input parameters. So if you can visualize the water quality portal interface right now, as Laura was just showing you, there was a field for HUC. There was a field for organization ID. There's a field for characteristic name. There's a field for dates, right? Every single one of those is a different input parameter. And so they resolve to one of these input parameters. So the organization resolves to this input parameter, organization. So if I wanted Utah water quality WQX's data, I just say organization equals Utah_WQX. And if I wanted it from 2006 onward, I would give it that start date low of 01/01/2016. And then these other two input parameters are pretty default. Give me a CSV file and go ahead and zip it up. If I don't want it zipped up, I just say zip equals no. And then at the end of it, what I get is this URL there at the bottom. Now I could take and copy and paste that URL into a browser right now, and I would get that data. I would get the data from Utah Division of Water Quality, and I would get all of their data that's been collected since 2006, and I would get it as a CSV file, and it would be zipped up. I never even have to go to the water quality portal interface. It's going to do that all for me. Very powerful. Now, why is this important? Now I want you to put your programmer hat on. So let's pretend that you're all programmers. All of us aspire to be programmers at some point in our life, right? So now you could replace any of those input parameters as a variable. So replace Utah Division of Water Quality with a variable that's like organization ID. Now what I can do is I can let a user say, pick an organization ID. I'm going to give you 5 to choose from. Pick one. And they pick one. I automatically generate this URL on the fly. I can go grab a different set of data. That's why this is so powerful. Super powerful capability. Another reason why web services are important is they allow us to be able to pull data together from multiple different applications together into one application. So this is just an example. So here's an example of maybe we've got a website that is showing monitoring information. So if you want to brand your data separate from the water quality portal, totally fine. You can have the water quality portal be your service that is providing all of the data, and you can have your own website with your monitoring locations on it and the ability to download data from there, all leveraging the water quality portal web services. You don't even have to build any functionality. Jesse's going to show you how to do that in using ArcGIS Online. You can do it in 15 minutes, and you've got a website set up that has your data exposed with the ability to download the data. And again, nobody even has to know that it goes to the water quality portal. Very powerful. Last thing that I'll say as well about this is that really you're only limited by your imagination and the portal's ability to respond to the request that you have. So you can really make it do anything. There are existing R packages out there. There's a data retrieval package that's been developed by the USGS, very powerful data retrieval package that allows you to be able to interact with the water quality portal directly using R. So you can just package up and say, this is the data I want. It goes out, grabs the data, brings it back in R, and you've got your data frames to start working with right away. Really powerful. You can do this in Excel. A lot of people are very familiar with working in Excel, being able to just manipulate data in Excel. It's pretty easy to connect Excel to a web service. You basically just point it to that URL, and it'll magically go out and grab the data, plop it into Excel for you. And let's say you wanted to refresh that later. There's one button in Excel you push. You just put refresh, and it'll go out and grab the data all new and bring it back and put it in your Excel spreadsheet for you. A lot of people don't know that Excel can do that. It's something as simple as Excel has that kind of capability. And then you can even go beyond that. There's all kinds of other tools out there that allow you to pull data in and start to do other things with it. Again, you're really only limited by your imagination. So with that, I'm going to stop talking. Are there any questions about web services in general? That's to give you the framework for us to move on to the next step.
So as Dwayne mentioned, you can take these web services and package and build an app around them in, well, you can use them in Excel, you can use them in a data visualization software used called Click, and you can also use them to build an app in a language like R. So there's actually an app that we have called the Data Discovery Tool, which you can download off of EPA's website, and it's built in R, but the great thing about it is you don't need to know any R to use it. And so it's totally based off these web services. So you download it, you don't even need to have R on your computer, and you open the folder that downloads, and you open this file called discoverytool.bat. And it does some stuff in the background, and then in a few minutes or a few seconds after it loads this, it opens a browser window with this nice interface that looks somewhat like the Water Quality Portal interface. So this is an R-Shiny interface running on your desktop, communicating with the Water Quality Portal through services. So you want to choose a query. For this one, I am going to limit it by county, essentially. And I'm going to limit it by date range. So we'll just do yesterday, and I do sample media as water, spelled both with a capital and lowercase w. And so then what you click is you do retrieve data. And so right now what it's doing is it's calling the service in the Water Quality Portal, and it says it got 25,000 records from 19 stations. I had to limit it earlier because it's a limitation of tool. I think it's limited to 100,000 records. If you try 250,000, yeah, if you try to do more than that, it just won't let you import. So then you click import data, and you get this little box that says downloading data, please be patient, because it's basically downloading all of the data from all these records from the Water Quality Portal into the R app that is running on your desktop.
We did have a question that came in through the webinar, and it was, what is the name of the package that Dwayne mentioned, where you can pull data directly from the Water Quality Portal through R, and that package is called Data Retrieval. So I already responded to that person, but just as a reminder, that's what that's called.
Okay, great. Now it says data import complete. And so you can click this check data tab, which gives you a summary of your data, how many non-detects you had, how many different parameters you had, how many duplicate records. You can decide what to do with your non-detects, and you can view your non-detects, and you can view your duplicates. You can view filter data that only shows results with units with methods, and duplicates have been removed. You can save the data, which saves it to a CSV file on your desktop. But the real power comes in the View Data tab. So this tab starts by showing a map of the different monitoring locations, and you have all these filtering abilities right here, where you can filter by organization, you can filter by parameter. That one might take a while. And you can see all your parameters here. But if you click a station, let me click, this one might be too big. Maybe I'll click, we'll try this one. So if you click a station and click select this location, you can see a table of all the data from that station. You can see a station summary, which, come on. Yeah, so you can see a graph of all the parameters that were measured at that station. You can see when those parameters are measured, what dates they're measured in comparison to each other as well. And then you can also have this parameter unit summary tab, which shows, so you can pick any 3 parameters and see how they correspond to each other. So if you want to see how, let's see. I mean, a good example of this would be like, see how dissolved oxygen and temperature correspond to each other. But yeah, you can like select any 3 and see, oh, when this one's low, this one's high, for instance. And of course, you can click this and save this graph that just generated as an image that you can put in a report or post on your website or that sort of stuff. And yeah, so the water quality, the data discovery tool is open source, and the code is EPA's GitHub if you want to modify it to add the ability to query by something like project ID that is not currently in the software. Yeah.
Just curious if you guys made any more progress with the data analysis tool? Kind of the step 2 part of this?
Yeah, so there is this data analysis tool for people who aren't aware that basically, so in this check data tab, you can click the save data, and then you can import that data into this data analysis tool, which takes your criteria and your assessment units and can help you figure out when certain characteristics went like above your criteria. And it's been in development for a while. I'm gonna let Laura speak on its current status. Okay, so now that we've seen one application of services, I'm gonna be talking about another application of services, which I'm a GIS person, so this one gets me excited. I'm gonna be talking about how to view water quality portal data in ArcGIS Online. So I just need to get into my ArcGIS Online account. So I have to EPA.
Is it free if somebody doesn't have an account?
Yes, you can get an ArcGIS Online account for free. So we're back at the portal. This will look familiar now. So I'm gonna look at a state. Let's do Colorado. And I'm going to limit this by date, just so we don't get everything back to the beginning of time. I'm not going to have an end date. And then I'm going to click, I want site data only for right now. Show web service calls. Here's the station web service call. So what you want to do is you just want to copy this. Now I've opened up a blank ArcGIS Online map. I'm going to say add layer from web. So the type I'm adding is a CSV file because, as you know, the water quality portal spits out CSV files from the services or from the specific service that I just copied. So I'm going to paste that URL I got. There's one little change I need to make to it. I need to put zip equals no, as Laura mentioned, and wanted that to be always the case. But so I changed it to that. And then I click add layer. So now what it's doing is it's going out and calling the water quality portal. And in a few seconds, it should give me a box. It's just getting the monitoring station data right now. There we go. And so now what I need is it's asking where is the latitude and longitude. And so I found the latitude. It's right here. tell us latitude, tell us it's the longitude. Click add layer. And now it's basically plotting those on the map. And so now it's, oh wow, too much monitoring going on in China over here. So now I'm going to just, for ease of viewing, make it so it's colored by organization formal name. And click done. And I'm going to zoom in to where this monitoring actually took place. And so now this is great. You have your monitoring stations colored by the organization that did the monitoring, and you can click them and see some attributes for them, see what station that is, and that's great. But like, why do you have these monitoring stations? Because you want to know data, you want to know results, and you don't have that right now, but you can. So what you can do is you can get that from a pop-up. So I'm going to remove the current pop-up and configure a new pop-up. So the way I do this is I have it display no attribute information. What did I do? I add an image. Yeah, that's how we do this. So I add an image. I make the title here of the pop-up the monitoring location identifier. And then I don't need a caption. And then I make the URL for the image that I'm showing. Usually for this, I just like take the Water Quality Monitoring Council image and make that there, so it makes a nice little. That's not right. Copy image location. Yeah, that's what I did. Oh yeah, there we go. And then you can link it. So you can link it to is the, oh wait, let me go back down here. Now I need to link it to the, so I go results, sample results, and I go to show web service calls, and then I copy that and paste that in, and it links. But this, and zip equals no. But if I did this and then clicked it, I'm not going to do it because it takes forever, it would download all the data that I queried for. So what I want to do is I want to add a parameter to this web service call for site ID equals, and then I can choose monitoring location identifier here, and that basically makes that a variable, although it puts it there, which is annoying. Set ID equals that now. And now I click OK, and I click OK here, and I click one of these. I get a little nice link box, links me to the portal, and downloads my result CSV for just that site ID. And if you open it, it should just be that site ID. Yep. And there you go. And that's a very quick and easy way to use services to get your data in ArcGIS Online.
Okay, so we're going to go over a couple different ways to explore this information. So I believe that you all to take another couple of different ways to take advantage of water quality web services. I believe you all got a link to a Google Drive folder.
Should have it. I think it's in that bit dot.
And so all the things that I put in that I'm going to show you are linked to from that folder. So so we're going to start with a really handy. So there's a tool called Jupe. So you've heard you can access water quality data through Python or through R, and one of the challenges is often, okay, I have to install R. I have to install Python. I have to convince my local IT that it's a good idea to install these things. And something that's pretty fun that's coming out on a number of different places are basically hosted R or Python, where you, as an individual, can basically someone else takes care of all that, and you just run things on the cloud. One of the examples, I'm going to show you one example, which is Azure Notebooks. So this is running off of the Microsoft Cloud. It appears that many of you, if your organization already uses Microsoft Cloud products like Office 365 or other things, you may already have an access to this because it's just through the magic Microsoft everything's connected reality. So we just tried this with EPA, and lo and behold, they could connect. So it's pretty fun. So we're going to show you an example of what we're doing here. And the other nice thing is you can pay for it, but there's a free compute tier that gets you pretty much everything you need. And you know, they're basically using it as a selling tool. So we're using what's called a Jupyter Notebook, which is a tool for presenting and running code. And so I've got one spun up here, and we're going to. The cool thing is that it does there's all sorts of fun stuff on top of this tool. So you can actually run a presentation of your live code, all running at the same time. So this is running live code, but it's also a presentation. So we're just going to run through this. So, oh, by the way, I'm Jim Kraft. I work for the USGS. I'm in the water mission area, so I'm technically in headquarters, but I'm actually in Madison, Wisconsin. If you're interested in the water quality portal, but also anything to do with USGS water data provision to the outside world, that I have a wide variety of hats and responsible for a number of different things. So I'm the right person to talk to, yell at, complain to, give great ideas to, etc. So I'm going to go over summary services. So summary services are services that currently you can't quite get to on the Water Quality Portal user interface because they're new enough that we haven't totally integrated them with the Water Quality Portal system, but they're really handy and useful, and they scale nicely, so I like showing them. You can use the query. I want to be able to. You can use the query parameters that are associated with location, things like county, state, bounding box, radius. And you can, oh, that's why it's doing. I'm losing a lot of pixels because this is an elderly thing when it's mirroring. So that's why I'm a little confused as to how this thing is shaped. But you can use site level queries, location level queries and site level queries, things like site type, organization, site ID, HUC, upstream and downstream, but not all of the result level queries, because essentially what we've done is we've pre-built and pre-computed a lot of information so that these summary services work quickly. So we're going to choose stream locations in Dane County. And
something that is worth noting is that you've got this at the bottom of when you fill out that form, which we've shown you before. You get a cool bookmarkable, shareable link at the bottom. So if you do the same query on a regular basis, or you want to share that query with someone else, and you click on that link, open a new tab. Hey, look! It's another fun fact. This is, since it's a responsive website, you can actually make it, you can zoom it out and it still works. But Wisconsin, Dane County, you guys go home. And stream sites, all filled in for me. I didn't have to type those in again. So that's just a handy little tool. So what we're going to do is we're going to import a few core modules. So this is where we're actually going to demonstrate a little bit of code. I've actually already run all of this, so I'm not going to run it again at this exact moment. But all of this was just run about 15 minutes ago on some anonymous cloud server somewhere probably fairly close to the Columbia River, where the power is cheap. So we're using the core module is Pandas, which is the core data science library for Python. So we have to build a query string to be able to get the data that we want. So we're going to grab a chunk of the web services query that we care about. Let's see if I can. Hey, there we go. Cool. So we're going to grab the state code, county code, stream chunk of the web services query and paste that into a variable that we've got called query fragment. And that's just a string, a Python string. Then what we'll do is we're going to actually build up the rest of that query parameter by setting in, hey, we want to be able to summarize by the last 5 calendar years. We want this, we're using the concept of data profiles in Water Quality Portal. And so this is the period of record data profile for summary services. There's also a different part of the summary services that we're still working on, which would be a different view of the data that's more compressed. We want CSVs, and in this case, we don't want to zip the data. And then we've got a little tool to build the query string that we care about. Awesome. So this is a query string. If I click on it, I'm going to load the data, and eventually, there it is, bing. And that's basically just a CSV. And now we're going to make use of it. So Pandas is sort of the giant toolbox of data acquisition and manipulation tools. One of the things you can do is just pass it. If you know you've got a web service call that kicks out a CSV, you can just give it that query CSV or read CSV, and it'll read a file, it'll read a URL, it'll do its best if it's CSV-ish to figure out what's going on. And you can also do all sorts of, you can clue it into a bunch of other things as well. So then from there we can do an initial exploration of the data. And what you can see is that the data are summarized one row at a time by a combination of monitoring location ID, year summarized, and characteristic name. So each row is a combination of those 3 key pieces of information, along with a number of other useful parameters that you might want to know, like what type of monitoring location it is, the name of that monitoring location, what organization it's affiliated with, the last result submitted date, which is, we don't have that information necessarily for USGS, but for, if you're in WQX world, that's the last result submitted date for that site, that year, that characteristic date. So you can see, and then you could also roll that up so you could find out if someone's adding new stuff way in the past, you can find that out. In this case, you can also get additional information. Basically, it's saying, hey, we got 2,700 objects here. Some of them are numbers, some of them are objects. You can actually tell pandas things like, oh, this is a date, other types of information like that. And then we can do some exploration. We can, some of the ways we can explore it, including grouping data, and then we can also do things like pivoting, which are exactly the same concepts as what you can do in Excel. The fun thing about pandas is that you can pivot on many millions of rows of data. I actually pulled the entire pandas data set, the entire summary data set, 62 million rows, into pandas, and can pivot on that all at once, which is pretty fun. It only takes about, it's an 18 gig CSV, but it only takes about 4 gigabytes of actual memory once it's pulled into pandas. Because that's the other thing about pandas is that unlike Excel, which underlying itself is these kind of bloated XML files, pandas is all about very efficient use of things like memory, so that you can use very large, pretty large data sets without having to jump out into the true big data world. This gets you basically to what you could consider medium data pretty easily, or pretty big data. So one example is, I want to roll everything up together to the organization and characteristic type. I want to see what organizations here on stream sites in Dane County in the last 5 years, and I want to summarize that by the total number of results available, and I want to split it out by characteristic type. And basically, what you're seeing here is that there's only 2 organizations, Wisconsin DNR and the USGS Water Science Center, and Wisconsin DNR is collecting an enormous amount of physical data, which might be a smell in the data, and something that happens occasionally is when you see huge amounts of stuff like that, probably means they've got a sensor that's kicking out high frequency data, but it's being kicked into WQX as a sort of a discrete observation. Okay, so that's something we'll do a little bit more exploration of. So then also we can say, hey, we want to roll this up by year instead of by characteristic type. So again, we've got our organization identifier. So Wisconsin DNR, USGS Wisconsin, and again, hey, it looks like they've got a pretty steady amount of data that they're putting in every year. So let's look a little bit farther as to what's going on there. And see what the top characteristics are, and see if we can get a little bit more insight into what's driving that sampling density. And oops. There's multiple dimensions in these slideshows, which is confusing sometimes. Okay, so what we see here is that, hey, look, we've got water. They've got a pile of probably hobos or something else out there that's collecting tons of water temperature. They've got 809,000 individual temperature records. And so that's something where the next step that I'll probably, if you watch this repo, it will. I didn't quite get to the point where we broke out the temperature data and then we're able to combine and look at everything else separate from that. That would be sort of probably a next step if you wanted to sort of see what was going on in the future. And you can do all sorts of other fun stuff in here. Basically, the other thing that you can do is things like mapping, all sorts of other exciting stuff. So, and the fun thing that I was able to do here is, the other great thing about that's running in the cloud, I was doing a lot of this stuff, I was messing around with it on the plane, and my internet was terrible. But it was just enough to ship data back and forth to that remote server. And the remote server had a great internet connection. and was able to do that stuff. And I don't know what your office is, but my very fine 7 layers of firewalls in work network sometimes has some challenges. So this is one example. So here's another thing that I wanted to go over. Any questions about that? Something else that's fun about these networks, I was doing this in Python. There's equivalent notebooks in the R space that to do this exact same thing, and actually even on Azure notebooks. Okay, so here's another fun way to be able to take advantage of water quality portal data. So we're going to take a look at, so we've got annoyingly, I lose my tabs. So we're looking for, so another way to, so let's look at, so this is a website here. And you'll notice this website is nwqmc.github.io/wqpdemos. And so this is a static website that is going out to that when you load the page, goes out to the water quality portal, asks, hey, water quality portal, what sites are in Denver County that have at least one sampling activity? And gets back a Geo JSON file, drops it on the map, and then the fun thing is it's styling the size of dots based on the number of sampling activities that were collected by this, that were collected at each site. And you can click on it and get some more information and jump over to the jump over to an error page, which is pretty fun. So I always get to. Okay, I'm going to stop worrying about that right now. And yeah. But this is again. But the cool thing about this, couple things that are really worth noting here. So I'm going to jump over to another tab that's behind these super handy boxes. So this is the source for that page. And the interesting thing is that it's on a off of the demos GitHub page. And it's a branch called GitHub Pages. And GitHub Pages are basically a way to quickly host static HTML content. And so you put this information in the right place, there's the content, and it lands, and then this is the GitHub Pages branch of WQP demos, and that's WQP, National Water Quality Monitoring Council, github.io/WQP demos. So that's a way, if you're allowed to use GitHub, a way to really quickly get static content out on the web. And you can also map a custom URL to github.io. Instead of having github.io, you can have whatever URL you want if you can get that control. And again, this is a web services driven thing. You can do all sorts of other fun stuff in that space. And if I was an actual web developer, I could have had a lot nicer little video, a little demonstration than what we've got here. Any questions on what's going on with this?
So where did it get the Denver County query from? Is that in your, that's hard coded in there, or
yeah? So in this case, it's hard coded. You can actually see right down here a get JSON, and then it's just getting a water quality portal call, a water quality portal web service call. So that's one thing, and this area and this repo of WQP demos is something that is going to grow over time. Right now we've just got basically a version of that same notebook that I shared with you, but I'm expecting to add additional things in that space. So let's see. One other way that we can explore, just Dwayne threw out the idea of using QGIS, and QGIS, it's really fun because QGIS acknowledges the existence of a concept of a format called Geo JSON, which is my biggest gripe with Esri products is they don't really use Geo JSON for whatever reason. I have my opinions. I'm not going to share them today. So the cool thing is QGIS does use Geo JSON, and it's really, really easy to do. So basically, all you do is I'm actually going to start a new project. Don't save. So you say, hey, QGIS, I want a new vector layer, and I want Geo JSON. And I think I still have that. Yes, handily, I haven't copy-pasted anything since the last time I did this. So this is the Geo JSON URL, that same web service call that we use to populate the web page. And QGIS says, cool, I know what to do with Geo JSON, and it appears. And then you can be like, hey, I want a map. And you've got lots of options. Stamen makes pretty ones. So we'll choose Stamen terrain. And there we are, those same sites. But in a QGIS space, and you can do all sorts of however fancy you want your geospatial analysis to be. You can also actually export a web map from here that you could then plop like a whole chunk of code that you could then plop into a GeoJSON IO page if you wanted to.
So this is how's my waterway. Again, it's really designed for a public communication of the data. I'm going to go ahead and enter a location. And what it's going to do is it's going to figure out which 12-digit HUC I'm in based on that location. And it's going to start going out, and it is going to grab data from the water quality portal. It's going to grab data from Attains. It's going to grab data from the 319 grants tracking system. So it's going to pull a bunch of information together. What you see there on the right-hand side is the 12-digit HUC outline. And then the streams are all identified there. The colors really get mangled on this screen. I apologize for that. And then what's interesting for the discussion that we have here, notice it's identified 80 monitoring locations. That's all coming directly from the water quality portal. So that's using these water quality portal services that we've been talking about already. So there are all of those water quality portal monitoring locations. I can click on any of those, and it'll tell me a little bit more information about that, tell me what kind of data is monitored there. And if I were to click on that, it'll actually take me to that monitoring station itself. I'm going to click on, just for the sake of time, I'm going to go to our monitoring tab, which again is pulling data from the water quality portal, and we're using those same summary services that Jim just demoed, and it is pulling up all the different types of data that are being collected there. Let me get rid of a little Microsoft Outlook here. And I can show those on a map. So if I want to see all the nutrient stations, I just click that. There are all the places where nutrient data are being sampled. And again, you can download the data directly from here as well. And like I said earlier, never even have to go to the portal. This is all taking care of it for you. So this is just another example of how having web services allows us to pull all kinds of information together. If you guys are interested, we'll have a much more detailed presentation on this tomorrow at the EPA booth, and then Thursday there is a actual presentation on this as well. I would actually recommend the booth. You probably get more out of that than the presentation. And Jesse, where would I find that Excel spreadsheet? And I'll show them that real quick. Any questions on this while Jesse's loading me up?
What was the short URL? There is one, right?
So this one is not publicly yet. So we're still working on it, and it's probably going to change some as well before we actually release it. We're looking to release it possibly mid-summer sometime.
Yeah, most state DEPs and DEQs submit that as a water quality report.
Just about.
Just about.
There's maybe a couple that are not quite there,
Okay.
but just about all of them. Yeah, I can actually only think of one right now that I think is not submitted.
This is part of most of their business process.
It's actually a requirement of their 106 grant, so they're required to submit the data to us. Okay, perfect. Thank you, Jesse. Okay, so this is that spreadsheet that I mentioned. This is just a pivot table. That's just Excel magic. There's really nothing magic going on there. This data tab has all of that data. So right now it's reaching out to Georgia. I've got the list of organizations in here. This also came from a Water Quality Portal web service. This is the existing list of organizations in the Water Quality Portal. If I wanted to refresh this, all I have to do is right-click on there and hit refresh, and it's going to reach out to the Water Quality Portal. It's going to grab the most current list of organizations and plop them in my spreadsheet. I don't have to do anything else. What organizations should we look at? Can we pick on the organization? We picked on Dave earlier. What is your org ID, Arnie?
It's a Matchbook 21COL001.
Okay, I won't even look it up here. Let's go over here. Okay, so I'm going to go to my data tab. I'm going to view my connections. So Excel has this idea of connections here. So each of these connections is a connection to a web service. I'm going to change this to be Arnie's organization. So this is my input parameter. We talked about services have the idea of an input parameter. So
21COL001.
okay, you got to go slower for me.
COL, not the case, that's the 001 underscore.
Okay. All right, so I'm going to save that. And then what I'm going to do is I'm going to come over to this summary one, and I'm just going to right-click on it. I'm going to say refresh. I'm going to cross my fingers and hope that our internet connection here works. So this is the nice thing of the demo that Jim showed, is that he's not relying upon our internet connection here. He's relying upon the internet connection between Microsoft and the network. I have found as I've been doing stuff that Amazon's connection to the internet is much faster than my connection to the internet. It's got it. Okay, it's downloading it right now. See, you can see the progress there. It's chugging through it. It's got about 7,000 rows that it's chugging in right now. When it's done, it'll magically show up in this spreadsheet. I don't know how many there's going to be. How many stations do you think you have on it? Okay, this may take a while. Because basically it's going to have a row for every parameter, for every one of those stations, for every year.
Yeah.
Yeah, is that right?
Take a while.
So it's going to probably take it a while. I probably should have picked this smaller. Kudos to you for having so much data.
No, I did that by a factor of 10. It's around 3,000.
Okay. My guess is normal state, it'll probably be around 50,000. So I would expect when we get around 50 to 60,000. It is only getting the last 5 years worth of data, so that kind of makes it a little bit easier. But yeah, once this is done, and I can go off and let that run for now, but what I'll be able to do is I'll be able to look at this spreadsheet, the same as what Jim was doing. There's really no different functionality. It's just inside Excel, and I can pick different characteristic types. I can pick characteristic names. I've got it organized by county, by HUC, so you can start to slice the data however you want to try to figure out where is the data, what data are being collected, when is it being collected, how much data is being collected by each year. So it's really kind of an easy way to try to really understand what's going on with your data. We originally worked with Jim to develop this functionality to replace the old Storette dashboard, if you guys ever use that. We're not quite there yet, but you'll see a lot of similarities. Yeah, that's basically what this is kind of given us, is an inventory report. That's exactly right. Which is handy, because you can then see what data have I collected. All right, so while this is chugging, any questions about this? So this is just WQP summary services. Yeah. Yes, this is in there. Oh, I think it's got it. It's done. 51,000 rows. So that was pretty close. So Excel does require me to do a refresh on this. So I'm just going to click here and say refresh. Okay, this is the test. We'll see. We're going to look at Arnie's data. Okay, there we go. So Colorado, it's actually pretty good. You guys are doing really good, actually. So there's the data submitted by year. So in 2015, about 80,000 results, data about true. 2017, probably still working on your 2018 data, I'm guessing?
Yeah, that's when I get back from this conference, I get 6.
There you go. That's really good. So, you know, as an EPA headquarters person, I would look at that and I would say, oh, you're doing a good job. This is great. And you're able to slice this as well. So we can say, all right, what kind of data is Colorado collecting? They're collecting all kinds of data. Let's say we're really interested in the bacteria. Let's see how that looks. Again, just the ability to do this and see the different kinds of data that are being collected and when, and the patterns of the locations. Again, these services are here to help you explore your data. Just another many examples of different functionalities that these services open. I'm sure you guys will think of others, and so that's the core message. But I think we're done. You guys have endured 4 hours of pretty intense training. Any last questions for us before we leave? Yeah.
Yeah, can I get